Substations. This type of substation is used to step up the voltage from the electrical power plant's generation voltage. Typically, generation voltages can range from 11 kV in Europe to 13.8 kV in the US. It is relatively economical to generate power at a lower voltage level and then step up the voltage to transmission level, 138 kV, 230 kV, 500 kV in the US. Generating substations are used to evacuate the power from the power plant to the transmission line. Transmission substations. These substations are located near the load center, and they connect two transmission lines with the same voltage level. A transmission substation may also contain a step-down transformer for converting the voltage to sub-transmission level, power quality enhancement equipment such as PFI capacitor plant, and static VAR compensators. The transmission substation has a responsibility to maintain a stable transmission line voltage and frequency. Sub-transmission substations. This type of substation is connected between a transmission substation and a distribution system. It is used to step down the voltage from the transmission level to the distribution level. Transmission voltages can range from 33 kV to 145 kV. Sometimes big industrial customers get their power line tapped from the sub-transmission substation. Distribution substations. Electrical distribution substations are located near the customer's load center, and they connect two or more distribution lines with different voltage levels. A distribution substation contains step-down transformers for converting the voltage from the distribution level to the customer's premises. Distribution substations can be from 11 kV to 33 kV and step down to 400 V. From distribution substations, electrical power is distributed to small industries, large commercial buildings, and residential customers through pole-mounted or underground substations. Converter substations. Converter substations are a special type of electrical infrastructure, mainly power electronics-based installations such as HVDC. High voltage DC, HVDC, is a power transmission technology that is often used as an intermediate step when converting between two AC systems. Switching station. A switching station is basically an electrical substation without any transformer and contains only circuit breakers. As there is no transformer, so they have only one voltage level. In some areas where there is parallel power source, switching stations carry out the task of switching between alternative source power in case of failure or planned maintenance. Mobile substation. Mobile substations are large trucks or semi-trucks mounted substations with a small distribution transformer and a couple of circuit breakers. These substations are designed to be transported to the site of the fault, where they will be set up and used to restore service. Underground substations. Underground substations are special electrical facilities that are installed underground, typically in urban and suburban areas where overhead lines are not practical, for the purpose of distributing electrical power to the above-ground area. They are buried several feet below ground, and then they are connected by cables to the distribution system. Pole-mounted substations. Pole-mounted substations are commonly installed by the utility company close to the area they serve. Pole-mounted substations can be used in new developments or in older neighborhoods where underground construction is impractical. Pole-mounted substations are commonly used for low-voltage lines such as 11 kV to 400 V. Elements of an electrical substation. In a typical electrical power substation, there are various electrical devices. A substation electrical engineer must know about those devices. Electrical transformer. Transformers are the most important component in the electrical substation. If we consider the journey of the electrical power, we will see electrical power is generated at 13.8 kV and then stepped up to a transmission voltage, let's say 138 kV. Then through a transmission line, the power is transmitted to a grid substation where this electrical power of 138 kV voltage level is stepped down to a suitable distribution level voltage 34.5 kV. In this whole journey, this all-voltage transformation is possible via an electrical transformer. Circuit breaker. In electrical circuits, a circuit breaker is an electromechanical device that opens and closes the electrical circuit. It is designed to interrupt the supply and/or the load as per the command given by the protection relay. The relay sends a signal to open the circuit breaker if the abnormal condition persists for a certain time, and the circuit breaker opens the electrical circuit to protect other vital equipment from damage caused by excess current from an overload or short circuit. In high-voltage substations, typically gas circuit breakers are used wherein the breaker interrupter chamber SF6 gas is being used for arc extinguishing purposes during contact breaking. Instrument transformers. Instrument transformers are used in electrical substations to measure and convert high voltage and high current to a standard level of voltages and currents so that they can be used in protection relay and metering applications. Current transformer or CT and voltage transformer or VT are known as instrument transformer. Protection relays. Protection relays are designed to protect the substation from any unforeseen, abnormal, or hazardous conditions such as overcurrent, low voltage, high voltage, under frequency, over frequency, overload, over temperature, earth fault, and short circuit. Disconnecting switches. A disconnecting switch is a mechanical device that opens and closes the electrical circuit. It is used when maintenance or repair work needs to be done on the equipment connected to the circuit. For example, if one of the transformers connected to the circuit needs adjustment or maintenance, the switch will be used to isolate the transformer from the circuit. Once the maintenance has been completed, the switch is operated to close the circuit and make it operable again. Lightning arresters. Lightning arresters are connected in parallel with the circuit to prevent the flow of an over-voltage condition caused due to lightning strikes. Usually, a lightning arrestor is the first element that is connected to the incoming electrical power lines. The working principle of lightning arresters is simple. When a lightning strike occurs, it creates a very high electrical current. This current travels through the conductor of the lightning arrestor, discharging it and allowing the current to flow to the ground. Substation busbar. A busbar is an assembly of metal bars or strips that carry large currents with low resistance. It is used to connect together two or more circuits of the same voltage level. All incoming and outgoing electrical conductors are connected to the substation bus. In a way, bus is used as a junction box. It's standard practice to use copper or aluminum in the construction of electrical bus bars. DC sources. In every substation, a DC source is available, typically as a battery bank. They are mainly used to provide the DC power to the protection relays, circuit breaker auxiliary power such as close and trip coil, and charging motors. Conclusion. After watching this video, electrical engineers should have a clear idea about what is an electrical substation, what its components are. Do you have any questions? If so, feel free to ask me in the comments section below.
Subscribe.